paper called Write Prints that was published last year, where they did a version of this problem. They did an unsupervised, they had 50 authors in an unsupervised stylometry problem and had 95% accuracy in determining if any two documents were written by the same author. So clearly the threat is there, even if the numbers are not totally telling just yet. A much bigger threat, though, is in supervised authorship recognition. We did a large study, which I'll go into detail within a few slides, looking between 2 and 5 authors, and found that with anywhere from 80 to almost 100% accuracy, you can figure out who authored an anonymous document amongst a group of 2, 3, 4, and 5 authors. Furthermore, there's other research out there showing that groups of up to 50 authors can be distinguished with up to 90% accuracy. So the point of throwing these numbers at you is to say that the threat of stylometry against privacy is real. It can be used against you if you're trying to publish something anonymously. So what is the study that we did? The problem we looked at was, can stylometry be attacked? Can stylometry be attacked? How so, and how easily? We performed an in-depth study looking at multiple methods of stylometry and saw how they held up against attack. And we came to the conclusion that stylometry is actually quite vulnerable to attack by inexperienced human adversaries. And these attacks can be used to help protect your privacy, protect your anonymity if you're trying to publish something anonymously. There is some related work in this field. There was some work done looking at authorship attribution and pastiche, looking at a author of a famous novel. In this case, it was Lewis Carroll, who wrote Alice in Wonderland, and looking at some imitators of his and trying to see if they can come up with a method of distinguishing between the true author and the imitator automatically. They had somewhat mixed results. And then a few years ago, there was some more research looking at how many words in a document needed to be changed in order to properly hide the author, the true author of that document. And they had a lot of success looking at seeing that only a few words need to be changed in order to successfully hide the author. Now, our goal in this case is not to look at how to specifically change a document, but really to assess the general vulnerability of stylometry when faced with human adversaries trying to hide their own writing style. All the results that I'll show here were published in a paper that Dr. Greenstead and I wrote called Practical Attacks Against Authorship Recognition Techniques, and that you can find on our research group's website, the link to which I'll put up at the end of the talk. There are 2 types of attacks we looked at in trying to get around authorship recognition. The first is an obfuscation attack, where an author simply tries to hide their own writing style without regard for who ends up being the target of that document. So they just want to make sure that the stylometry system does not identify them as the author. The second is an imitation attack, where an author attempts to write a document in order to, you could say, frame another author. They want to write a document so that the systems think that they are specifically another author. So these are the 2 attacks we looked at as ways to circumvent authorship recognition. We looked at 3 representative methods of stylometry, which I'll go into in detail. We had 15 participants, and participation had 3 parts. First, we collected 5,000 words of existing writing that was not tampered with in any way. We collected 1 obfuscation attack passage and 1 imitation attack passage. Now, we gave the participants specific tasks for these passages. The first was to describe their neighborhood, and the second was to describe their day. We gave these specific tasks because we wanted to eliminate as much content difference as we could, so we knew that we were really studying the writing style and not distinguishing authors based on other factors. For the imitation attack passage, we also chose an author, Cormac McCarthy, who wrote the book The Road. Some of you might be familiar with. It was recently made into a movie, and I'll talk a little bit more about that in a second. And an important note is that authors had no formal training or knowledge in linguistics or stylometry. These are just people that we said, generally they were college graduates, but they had no background in linguistics. We just said, hey, try and figure out if you can hide your writing style. Just think of what your writing style might be and write a new passage trying to hide it. So for the imitation attack, again, we picked Cormac McCarthy. We thought that he had kind of a distinct writing style that people would be able to get interested in trying to imitate. The passage was pretty engaging. We thought, well, if we have an interesting, engaging problem, we're going to get better results from the participants. So as you can see, he uses some pretty dark, descriptive language. And it was actually kind of funny. We had some pretty interesting examples of people trying to imitate his style in talking about their day. So people like talked about brushing their teeth and getting coffee in these really dark, gloomy ways, which is kind of entertaining. So I have hundreds and hundreds of words of these passages too, which is endlessly entertaining. And you all will get to read them at the end, which is also funny. So yeah, thought you might enjoy some of those. So there's two experiments as part of this study. The first is the validation experiment. We wanted to make sure that the stylometry methods that we were using were effective to the degree that the authors that made them said they were effective by testing them on a new data set. Then we wanted to do the attack experiment where we fed this attack data into the stylometric methods and looked at how accurate they were after this attack data was submitted to them. Each test was applied to unique sets of 2, 3, 4, and 5 authors. We did this because most stylometry research actually only looks at 2 or 3 authors, and we wanted to expand upon that a little bit. We used the same sets of authors for each method, and all the accuracy numbers that you'll see were done through cross-validation. So they were very, very, very thorough. These are very thorough accuracy numbers. Now, I assume many of you might not be familiar with artificial intelligence and machine learning. Machine learning is a term I threw around a few times in this lecture, so I just want to give you a brief overview of it. The basic idea behind machine learning is that it is AI. Machine learning is an area of artificial intelligence. The idea is to learn and recognize patterns automatically and then make decisions based on those patterns. The most common incarnation of machine learning is a classifier, and all of you, I'm sure, use an incarnation of machine learning in your spam filter, or whatever spam service you use. Most of them are some form of Bayesian classifier. And that when the message comes through to your inbox, it makes some determination based on the features of the message as to whether or not the message is spam or not. When I say feature, I mean some measurable item within the message that you can use to determine whether or not it falls in one category or another. So in many spam classifiers, it'll take a word and say either this word is indicative of spam or it's indicative of normal message, and that word is the feature. So it's important in machine learning to pick good features, and all 3 methods we used different sets of linguistic features to try and really cover a large amount of ground in stylometry. There are some basic measurements that we did, such as the average syllable count, average word count, things like that. We had some more complex measurements like the lexical density, which looked at the ratio of unique words to total words. And then we had some even more advanced measurements, such as the Gunning-Fogg readability index, which incorporated sentence length, complex word ratios, and gave some sort of measurement as to the level of education that should be expected to read a document. The first method we use is actually just an out-of-the-box stylometry method called signature. It only used 3 features: word length, letter usage, and punctuation usage. I guess you could say that the letter usage feature is actually 26 features because it used all 26 letters in the alphabet, but for sake of argument, we'll say it's just the 3 features. And we had about 95% base accuracy in looking at the untampered data, so it was a very effective method. The second method was a neural network classifier. It used 9 different features, including lexical density and the readability indexes, like I said, including a number of others. Again, details of all these things are in the paper, so if you really want to know what these measurements are, you can go read about it or ask me later and I'll explain them to you. We had almost an 80% base accuracy, which is not as high as the others, but is still quite high in determining the correct author. And then just an overview of neural networks. The idea of neural networks is an artificial intelligence technique meant to, in a way, mimic how the human brain works, where you have a number of input nodes. Each input is a feature from the text, and those input nodes feed into other nodes, and in this case, there are simulated neurons which fire, so to speak, if a certain threshold is reached. And then, in the end, you are left with the node, the classification node that is correct, being fired, and that being your classification output. Again, it's not terribly important for the sake of this talk, but I thought I'd mention it. And the third method was a synonym-based classifier. This one is unique in that it looks at not any of the sentence structure of the text, but the actual word choices. So here's an example of two authors. One is Noam Chomsky, and one is this author X. The Noam Chomsky passage is colorless green dream.